For centuries, humans have imagined movement beyond the wheel, a way for machines to step, climb, and balance with the same quiet confidence found in living creatures. The dream was simple, yet extraordinary, to create metal partners that could walk through the world the way nature intended. It was an idea that felt closer to mythology than machinery, yet generation after generation kept returning to it, convinced that one day steel legs would move with the certainty of muscle and bone. And so began one of engineering's strangest chapters. Our story takes us to the mid-20th century, a time when technology was accelerating faster than ever before. The Cold War pushed nations to think beyond limits, and the United States military wondered, what if vehicles didn't roll, but walked? What if machines could march across jungles, step over boulders, and navigate snowfields where wheels failed? These questions weren't theoretical fantasies. They were real military discussions, fueled by a world racing toward new frontiers of mobility. From that question came one of the boldest prototypes ever built, the General Electric walking truck, also known as the Cybernetic Anthropomorphous Machine. Standing nearly 10 feet tall, it wasn't just a vehicle. It was a four-legged beast of hydraulics, steel, and raw ambition. Each limb had its own power system, controlled not by computers, which barely existed at the time, but by a human pilot strapped inside a cockpit of levers and pedals. To sit inside it was to feel like a puppeteer for a mechanical creature that wanted to learn how to walk. To operate it was a test of strength and endurance. The pilot had to coordinate all four legs manually, shifting weight and timing every step. The walking truck could lift its feet, crouch down, and even climb over small obstacles. Its movements, though slow, were strangely lifelike. Watching it was eerie, as if the machine itself was discovering how to move with each uncertain step. But there was a problem. Controlling it was exhausting. After only a few minutes, the human operator would tire long before the machine did. The idea worked on paper, yet reality proved far heavier. The walking truck became a symbol of a brilliant concept trapped inside the limitations of its time. Still, the attempt changed everything. For the first time, engineers faced the true complexity of walking: balance, coordination, stability, challenges nature had perfected over millions of years. The walking truck taught them that legs were not simply mechanical parts. They were systems that demanded an entirely new way of thinking. Outside military labs, another industry discovered its own need for mechanical legs. In the 1970s, European engineers began building walking excavators, strange, spider-like diggers designed for steep mountainsides where traditional vehicles simply sank into the earth. These machines didn't walk gracefully. They moved slowly, carefully, almost like giant insects searching for footing on the rocks. But they worked. Their legs could anchor into cliffsides, stretch over obstacles, and maintain stability where wheels slipped helplessly. Even today, modern walking excavators remain essential tools in alpine engineering, proof that sometimes walking really is better than rolling, especially when gravity becomes an enemy. Yet for every success, there were failures. Walking was never simple. Each leg added more joints, more hydraulics, and more opportunities for mechanical failure. Sensors were primitive, computers were weak, and a single misstep could topple an entire machine. Some prototypes collapsed under their own weight. Others were too slow, too unstable, or simply too expensive to justify. Many were abandoned in warehouses, becoming forgotten relics of an era filled with impossible dreams. But all of them left behind clues that future engineers would quietly harvest, building a foundation brick by brick. As the decades moved forward, universities in Japan, Europe, and the United States began studying locomotion with fresh eyes. They watched insects, spiders, and animals. They tested early humanoid robots, labs filled with six-legged walkers, tiny robotic bugs, and awkward human-shaped prototypes that wobbled more than they walked. They looked strange, they were fragile, but they represented a turning point. For the first time, robotics wasn't just about strength, it was about intelligence, sensing, and balance. Every misstep became data. Every crash was a lesson. Engineers began to understand walking not as a mechanical act, but as a rhythm, a controlled fall forward, corrected thousands of times per second. Walking became a problem solved through information as much as hardware. By the 1990s and early 2000s, computing power had finally caught up with ambition. Better sensors, faster processors, and new algorithms unlocked possibilities that were unimaginable during the Cold War era. Then came the modern age. Companies like Boston Dynamics, Honda, and ANYmal finally achieved what earlier generations could only imagine. Their creations, Atlas, Spot, and ANYmal, move with a grace that borders on unsettling. They run, jump, climb stairs, and walk over debris with balance that challenges our expectations of machines. Powered by advanced sensors, real-time mapping, and artificial intelligence, these robots think about the world the way humans do. They detect weight shifts. They adjust their center of gravity. They react to sudden changes in milliseconds. What once required a full-body harness and a pilot's total concentration now happens automatically. Beyond Earth, new dreams are forming. NASA and space agencies around the world are testing legged robots for lunar and Martian exploration. On alien landscapes filled with craters, rocks, and unstable soil, wheels may fail, but legs could lead the way. Walking robots may one day descend into Martian canyons, climb lunar ridges, and explore worlds untouched by humans. On our own planet, these machines are already saving lives. Legged robots enter disaster zones after earthquakes, inspect dangerous nuclear sites, and navigate mines too unstable for human crews. Their value goes far beyond novelty. They step into places where human legs cannot safely go. And yet, behind every modern robot stands a long line of ancestors. The walking truck, the early mining walkers, the insect machines of the 1980s, the prototypes that stumbled and fell so others could stand. Each one carried a piece of human ingenuity, our persistence, our curiosity, our refusal to give up simply because something seems impossible. Walking machines were once heavy, loud, and inefficient. But they walked so that the future could run. Someday soon, legged robots may traverse alien worlds, repair our cities from heights we can't reach, or explore the deepest parts of our oceans. Wherever they go, they will carry a century of imagination, the legacy of inventors who dared to give machines legs. And perhaps that is the true magic of walking robots. They do not just move through the world. They carry the story of humanity's endless desire to push beyond the limits of what seems possible. If you enjoy these deep dives into forgotten machines, consider subscribing to MechVault, the home of engineering's strangest ideas and its boldest breakthroughs.